Hey guys, Mr. Gron, 10.1 arcs and sectors. In this video, we're going to be going over some of the vocab related to arcs and sectors, as well as finding the measurements of arcs and central angles. Okay, so our circle vocabulary and some basics, right, that we need some foundational stuff. Now, circle, we know what a circle is, right? It looks like this. For our purposes, what we really need to be comfortable with is that a circle, right, equals 360 degrees. And we also have a half circle called a semicircle, and that is equal to 180 degrees, right? So full circle is equal to 360. A semicircle is equal to 180. That's supposed to be half of a circle. All right, a couple other definitions. Our radius, right? We know the radius is half the distance across, so this is our radius. And the diameter is the full way across when it passes through the center, right? So it has to pass through the center, go all the way side to side. That is our diameter. Okay, so what is an arc? An arc is a portion of the edge of a circle, right? So if we have something like this, and let's say that usually we're going to have 2 points defined on the edge of the circle. So let's say that we've got A, we'll say this is B, and we'll put a C down here, right? So if I say arc AB, right? So if I say arc AB, that is this from A directly to B. If it's just 2 letters, it's less than 180 degrees. It's on this side, right? Now, if I want to talk about the other side, if I want to talk about from A to B the long way, well, then I need to include this third letter, right? So if it's just AB, it's implied that it's the shortest distance. If I've got something like this, where it's, let's say, arc ACB, that means I'm starting at A, going to B on the way through C. So starting at A, going through C, ending at B. Okay, so central angles, how do they relate to central angles? So we've got our arc here, right? This outer part, that is the arc, right? That goes from here down to here along the outside. Well, if we take those 2 points and we make lines, we make 2 radii, 2 radiuses to the center, and we measure that angle in the middle, this is called the central angle. And those 2 things are equal to one another. That's an important property that we're going to use to solve some problems. Okay, so looking at this. Now, a lot of these, you just kind of have to know what that relationship is to understand these. Now, we want to find the measure of arc xz and the measure of arc xyz. So xz is going to be this distance right here, right, that arc. Well, we know what the central angle is. It's 115. So arc xz, that is also equal to 115 degrees. Now, if we're talking about xyz, well, now I'm talking about the other side. I'm starting at x, I'm going through y all the way to z, right? Well, there's 360 degrees in the circle. 115 are over here. That means the rest of them must be on the other side to make that full circle. So what we can do is just do 360 minus 115, and that gives us what? 245 degrees. Make a better 5 there. All right, similar on this one. We've got arc AB and ACB, right? So AB, that is the short distance, and so that matches that central angle of 95 degrees. ACB, now we're starting at A, we're going through C on the way to B. Well, that's the rest of the circle, 360 degrees in a circle, so 360 minus 95. And that is 265 degrees on that outer part. All right, a little bit more complicated. So we've got some angle addition here. We want to find the measure of these arcs. So arc AC, that is going from A to C in the shortest route, right? So I know B is, we didn't call it A, B, C, we just said AC. Well, if it's just AC, that implies the shortest route, not the long way around. And now that's made up of two parts, right? This part out here from A to B is 73 degrees that matches the central angle. This from B to C, its central angle is 43. So if we put those two together, AC is 73 plus 43 is what, 116 degrees total. All right, arc AD. Well, now we are talking about AD, the short way. Now, I don't know what the central angle is here, but I know what all the other angles are, and I know that the whole thing's going to add up to 360. So if I take all of these and I subtract them from 360, that should give me the arc for AD. So that is 360 minus 43 minus 73 minus 104. I'm going to cheat and just look at my key instead of trying to do it in my head, and that should equal 140 degrees. All right, and then the last one, BDA, 3 letters, so I know it's more than 180 degrees, and it's going from B through D on the way to A. That is all of these central angles together except for that one, 73. Now I know this one's 140, so I could add these 3 together. Or if I didn't know that, I could just subtract the 73 from 360. And that would be what, 287, I think. All right, one more. So somewhat similar, I've got a bunch of parts. Now what's going to be important on this one is to understand how 180 degrees relates to this, right? We got a full circle of 360 degrees. I also know from E to B, that's a semicircle, right? So that's half a circle. Half of 360 is 180. All right, so for DB, let's see. The shortest route from D to B is like that. And that's the 100 and the 50. So 100 plus 50, that equals 150 degrees. Let's see, BAD. So that's this one from B through A on the way to D. Well, I know it's 180 degrees on this bottom half. And so this is going to be the 180 degrees to E and then 30 more degrees to D. So 180 plus 30, that equals 210. And then EA, all right, from E to A is right here, the short way. Now I got to think back to vertical angles, right? I've got straight lines cutting across, that makes 2 vertical angles in the middle. That means if this is 50 degrees, this other side is also 50 degrees. And so that one is just 50.